Now that we've got our hinges, we have to think about the layout, and the layout is absolutely critical to this whole project coming together properly. Now here's one of the legs that I've already cut my mortises in, and I'm going to sort of go backwards and show you how I arrived at this point. First of all, I laid the leg onto the workpiece in the exact way it's going to be installed when the time comes. So what I did was hold the hinges up and just kind of looked at it to see where they looked the best. I'm going to have some kind of joinery connecting the leg to the side as well, so I want to make sure everything works and doesn't, we don't have a hinge laying in the same spot that I want to put a dowel or something later. So I decided about 8 inches up from each end is where I want those hinges to be. Now the idea here is not to mark the lines that indicate where the hinge starts and stops. That gets very confusing and it multiplies your error. So what I like to do is mark the center points of those hinges. And if we do that, that actually makes it easier to design a jig for our router later. Now this very, very simple jig is the key to this whole process. Basically, it's just made out of strips of plywood, and there's a center line in the middle here, and equally distant from the center line are 2 stops, and that's going to stop the router base from going too far in one direction or the other. And you have to have those placed in precisely the right location, otherwise it's going to be off. So here's basically what you do. It attaches to the side of the leg, you match up the center point with the center point that you've already put on your leg, clamp it down, and now the router can only go so far as you go from one side to the other. Okay? Now to make this little thing, it's very simple, but you definitely do not want to do this with your final workpiece. You want to grab a piece of scrap and essentially draw, with a pencil, draw the location of your hinge. And that means drawing the outside edges of where it's going to go and the center line. So the idea now is you're going to use the router freehand and take it as close as you can to those pencil lines until you get it perfect. And you want to make sure that that hinge fits absolutely perfect in there. Now, it may take you a couple times to do that because that's the reason we're designing the jig. If we could do it freehand every time, we wouldn't have to design a jig, but that's not the case. So as soon as you get one that's perfect, you could stop there, take your router, unplug it, rotate the bit so that the blade, the furthest reaching part of that bit, is in line with the mortise, like so. Oop, we got to go this way. Plunge the bit down into the mortise you've already created, and then put it to one side as far as it'll go until it hits the wall of that mortise. And then I took my pencil and I mark where the base stops, right at the end of the base. Then I go to the other side of the mortise and I mark where the base stops on that side. Okay, and those lines represent the location where we need to place these stops. So I line up, I already put an arbitrary center line on here just so that I have it for reference. I put that on the workpiece, and basically glue and brad nails is all it takes to attach these little perpendicular pieces. Now the thing is, there still may be a little bit of error here and there. So I did another test cut using the jig this time. I've got a couple of them on here. And if it's a little bit too tight, all you need to do is take a little sandpaper, maybe a chisel, and take a little bit off the inside edges here so that the base can go just a little smidge further. If it's a little bit too loose, you could always use blue tape or something on the inside edges to kind of, bring it in just a little bit. But as simple as this little tiny thing is, and it's probably a one-time use deal, I'll throw it away when I'm done, it's going to make this process so much easier and that much more precise. And when you're hanging doors like this, precision and accuracy is absolutely key. So let's jump right in. I have another leg here that I haven't put my mortises in yet, and let me show you how it's done. Now just a quick tip concerning the router, and this may be common sense for some people, but I know it wasn't for me. Do not touch the settings on this router. In fact, put it on the other side of the shop and don't touch it again until we need it for the doors. These settings on here, they're pretty fine-tuned, so if we take everything apart and have to get it exactly back in the same condition later, chances are we're not going to hit those numbers. So Let's make sure that we put it on the side, we don't touch it at all, and when we need it for the doors, everything is going to be set exactly where we need it. Now the second part of this process just could not be any easier. All we need to do is create a deeper hole in the center of the mortise that we just made before. You can see with the shape of the hinge why we need to do this. This part in the middle here needs to set down all the way. So the easiest way I know to do that is at the drill press using a 1/2-inch Forstner bit. Now the last thing I need to do to the legs before we can actually start cutting the shapes is to consider whether or not we're going to use any joinery to attach them to the case sides. Now you don't really have to, but consider the fact that once you cut the shape and it looks something like this, the leg may decide to move or change a little bit because we're removing so much material. And if that happens, it would really be nice to have some pre-milled mortises that we can use as reference to kind of twist it back into position, even if it's just that little slight amount. So attaching this to the side is really not that big of a deal. You don't really need anything in terms of strength. What you really need is just alignment. So biscuits are fine, dowels would be perfectly fine, but I'm actually going to use dominoes for mine. But really, the long grain to long grain glue bond is certainly strong enough, but this is going to make our lives a little bit easier. So first thing I do is I've got my square set up so that it's exactly the distance it needs to be to center this leg. I already had this adjusted. And I'll use this on every one of the legs to make sure they're all consistent. And all I need to do is put a pencil mark wherever I want a domino. I'm only going to use 3 here, so one in the middle and one on the end. Well, you know, it's like my stepdad always says, measure twice and cut once. When I took the case apart, I laid out my shelves, and this was all before I was ready to cut the dominoes, and when I looked at the placement of the shelves, I realized I might have an issue with the placement of where I want to put my dominoes. I really don't want the domino to fall in a spot where there's a shelf. It's just not going to make sense to have it there. So the one in the middle that I had marked actually does get in the way. The one at the top is fine, the one at the bottom is fine. So this is where the middle shelf is going to go, and I'm just going to go a little bit above that. So right about here is going to be the location of my middle domino. But that's definitely something you want to be aware of. We've got our mortises for the hinges. Now I have the locations of my shelves, and now is the time that I could pick the locations to put those mortises for the dominoes, or if you're doing dowels or biscuits, you do the same thing. Now to be as consistent as possible, I'm going to take these initial marks on my first leg, and I just transfer them over to, this is going to be the left rear leg right here. So basically you line them up, make sure they're perfectly even, and just transfer that mark over from the one to the other. And this ensures consistency across all the pieces. Now I'll do the same thing with the other legs. Okay, here's the other front leg. Once it's even, just transfer those marks. And since I will be putting domino joinery on the front and the back, I'm going to take these front marks that I made earlier and transfer them to the back for later. All right, so now to transfer these marks to our other side piece as consistently as possible, I go back to my original first set of marks. As long as you keep using that first set, you really help to make sure that things stay consistent. Butt them up against each other, make sure the top is with the top. Line them up to the best of your ability with your fingers, which are very sensitive. And now I'm just going to transfer those marks to the new board, to the other side. And again, same way I did it 2 seconds ago. I'm going to transfer those to the back of the piece. Now I know I joke around sometimes when I say things like throw away your tape measure, but this is a good example of what I'm talking about. Transferring marks from the original board to each one of the legs and the other side really ensures consistency from one piece to the next. Whereas if we took measurements of where those were, then we grabbed our tape measure and marked out the locations on each one of those, there's a lot of factors that could result in that being slightly off, or cumulative error could occur. But doing it this way ensures that we have consistency across the board, and that's really the most important thing if we want this cabinet to stand straight and flat and off all four legs to hit the table at the same time and to be level with each other. And they still might not be perfectly level. We may have to level them, but this at least is the technique that stacks the cards in our favor, and I think it's a lot easier. It's a lot easier to transfer one mark from one board to another than it is to memorize 3 numbers and use a tape measure to lay that stuff out.
Whether using dominoes, biscuits, or dowels, making the holes is the easy part.
Now when you're doing your joints for the back, you've got to remember that there's a rabbet back here and a back panel. So if you have a perfectly centered hole, you're going to be very close to your edge. So make sure you make an adjustment on whatever joinery system you're using to center it after the rabbet. Now before moving on, I'm going to do a little dry fit here just to make sure I didn't screw anything up, and just make sure everything comes together the way it's supposed to. And that looks pretty good. I like it. I like it a lot. Now making the dados on the sides for our shelf pieces is going to be pretty easy at the table saw. I just have my dado stack set up to a 1/2 inch. I'm going to use my fence for reference, and I have my miter gauge set up with a nice fat MDF sacrificial fence. And what that's going to do is support the back end of the cut and help us avoid tear out. So let's get started.
I start with the bottom dado and work my way up. Be sure to cut both side pieces before adjusting the fence for the next cut. The third and final dado doesn't have enough support, so I move the miter gauge to the right slot, set up the fence, and make the cut. When possible, I try to reference all of my cuts from the bottom of my side pieces, and that gives me the most consistent results possible.
Now the side panels get a rabbet in the back in every compartment except for the bottom one, and you'll see why later. So essentially I need to make stopped rabbets. Okay, we can't go all the way through, because if we go all the way through the top, that's going to be seen. The top piece kind of will sit like this, so it's going to cover most of it, but we can't go all the way through. So I'm going to use a rabbeting bit on the router, at the router table, to make that cut. And I really don't like making this type of cut when I don't have to. I really like to be able to start at the beginning of a workpiece and go all the way through. Starting and stopping in the middle of a board is just, it's not my favorite thing to do. So if I could find other ways to do it, I will. But in this case, I really can't find any alternative to this. So the good thing is, we've got a little bit of free space here where I could start the cut, because the dado from the table saw is already in place. So that's going to give me an idea of where to start. And I'll start a little bit inside from that, and we'll just carefully cut across. Now Bubinga is pretty dense, and although I have a brand new Eagle America bit in there, and I'm sure it's going to do a great job, I want to know how this wood is going to respond. Now every piece is different, but I could still get a pretty good idea of what it's going to feel like and how it's going to act. And also, maybe I need to make the cut in 2 or 3 passes and don't take it all in one chunk. And doing a test piece is what's going to give me that information. So the first thing I'm going to do is make a quick cut. I'm going to pull the fence up a little bit so I'm not getting all of the bit in one shot. And there is a bearing on the bit here, so I don't really have to worry about fence placement all that much, because the bearing is eventually going to stop the wood from going in too far, and it's going to give me the exact dimension cut that I want. So let's do a test cut and see how it goes. So even though the wood is really dense, the bit is sharp. We're going with the grain, So this cut was perfect. I really see no reason why we can't just do the entire cut in one shot. So the idea will be to line up the fence with the bearing, and that way we'll have dual support and I could run my pieces all the way across.
When doing stopped cuts at the router, I like to have some part of the workpiece touching the fence before I make any contact with the bit. Take your time here and let the bit do its job.
Well, now I'm going to clean up the Dados and Rabbets, and for me, my new favorite tool for this is the router plane. It's just perfect for this task because you set it at a known depth and just move it all around, and it removes material wherever it's supposed to remove material. Now, one thing you'll notice when you do that is just how uneven these grooves are, and that's a painful reality that I've been dealing with for the past year, is realizing what I thought of as being flat, things that come off in the machines, what I think are flat, grooves that I think are perfect. These look perfect to me, but the reality is, once I put this guy on there, we're going to see just how imperfect they really are. First of all, this board was milled probably about 3 or 4 weeks ago, and I just haven't been here, so I haven't been able to work on it. So even if it was pretty close to being dead flat, it's probably not now. I'm sure it's got a little bit of a bow to it, and we have to be able to deal with that. So there's a couple different scenarios, and I think the only way for me to explain it is to show you with a hand-drawn diagram, and I've got that right here. So check this out. Now here are the 3 different scenarios. We've got the perfect world at the top, where we've got a nice flat board that goes over the dado stack, and our cut here is perfectly even all the way across. That's perfect. The reality is that most boards are just not perfect. You're going to have some slight curvature in there. Obviously, any major problems, you want to go back to step 1 and try and get to the point of having a perfect board. My boards were relatively perfect, but I had to leave them sit for about a month, and now there's probably a little bit of a curvature that I have to contend with. And you can sometimes clamp that out, but only if the conditions are right. Look at this board. If we run this across a table saw, well, the blade is going to cut at a fixed height no matter what we do. So what will actually happen is the dado itself will be a little bit shallower in the center than it is at the ends. And if you go and clamp this to another board, let's say you put your cabinet side down into that dado, the side is going to sit perfectly in that dado, and it's going to basically register against the bottom of the dado. And it, you know, as far as its perspective is concerned, is perfect. The problem is you've got a bowed cabinet out here, and you can clamp it all day long and nothing is going to straighten that out because we've got perfect contact at the bottom of the dado. So the solution to this problem is to make the depth of that dado even all the way across the board, despite having a few little imperfections in the surface. And that's what we're going to do over here. So the router plane can come down, with it, let's show it on this one, with its little L-shaped blade, and as you run it across, can make that the right depth. Okay, and if you do this, think about clamping this now. We bring a board down, it's a nice square board. If you run a clamp down the center, it's almost like a sprung joint. As soon as you clamp it in the center, the pressure is taken care of on the outside, you close it up, and what you end up with is a perfect cabinet with a nice flat side. We basically took that curve out of the board. So that's kind of the concept in a much more exaggerated example than what we're really dealing with in the shop here, but you get the idea. Now I know for a fact that the dados I made on the table saw, the cross grain ones, are a little bit high. So I know I'm going to remove quite a bit of material when I do this, and the reason for that was I knew that my router bit could give me a much more clean surface at the top edge, and going cross grain with a dado blade makes a pretty rough and uneven surface. So I expect it to be a little bit off. But you'll get an idea of how the router plane works. Basically, I set it to the back depth here. Okay, it's got a bunch of little adjustable knobs here that you just tighten. One raises and lowers it, and the other tightens it in place. And I just basically go cross grain. This is just one of those dummy-proof operations, which is good for me, because you just can't go any deeper than the tool is set to allow you to do it. Okay, and I won't go all the way to the end just yet. Sometimes it helps if you skew a little bit. because I don't want any tear out. I'll flip the tool around. Go this way. Now that I skimmed the top, basically, I'll go back through and put a little pressure on it. There we go. And that, my friends, is a perfectly flat bottom dado. Now on both the top and bottom, I did stop short, so it's also necessary at this point to come back with the chisel and just knock off the little tab that's at the bottom and the top.